Hi guys! See you again in Chapter 4, Introduction to Organic Chemistry. But this is the last subtopic in Chapter 4, which is 4.4 Reactions of Organic Compound. So guys, let's start! Okay guys, we start with covalent bond cleavage. All chemical reactions involve bond cleavage and bond making. Bond cleavage refers to the breaking of bond. So, in bond cleavage, we have two types, which is the first one, we have homolytic cleavage, and the second one, heterolytic cleavage. So, in homolytic cleavage, it will occur in a non-polar bond involving two atoms of similar electronegativity, like this. For example, you have chlorine molecule. So if we draw the structure, it should be like this, consists of one covalent bond or one single bond. So in homolytic cleavage, a single bond will break symmetrically into two equal parts, like this. So this single bond, we know that consists of two electrons. So one of these electrons will move to the other side of chlorine. For example, will go to this side of chlorine. Another one electron will move to this side of chlorine. So look at the arrow that I use here. The arrow that I use here is half-headed arrow. It means that movement of one electron. So this bond will break symmetrically into two equal parts, leaving each atom with one unpaired electron. So it will become like this. Cl dot plus Cl dot. Dot refer to the electron. So the homolytic cleavage will occur in the presence of UV or sunlight. The function of UV here is to provide energy for homolytic cleavage. So the product form actually is free radicals. So this is homolytic cleavage. Next is heterolytic cleavage. Heterolytic cleavage occurs in a polar bond involving unequal sharing of electron pair between two atoms of different electronegativity. For example, we have HBr molecule. So we know that in HBr molecule, bromine has higher electronegativity compared to hydrogen atom. So in this heterolytic cleavage, a single bond breaks unsymmetrically. Both the bonding electrons are transferred to the more electronegative atom. So we know that two electrons at one single bond will transfer to the more electronegative atom, which is bromine. Yes, look at the arrow that I use here. So I'll use the full-headed arrow. Alright, means both electrons will transfer to bromine. So the product form is cation and anion. So we know that one of the electron at hydrogen donate to bromine atom. So hydrogen become cation with positive charge, while bromine will accept the electron from hydrogen and become an ion with negative charge. So this is heterolytic cleavage. Next, we look at relative stabilities. The type of relative stabilities consists of three types. First, we have free radical. We know that class free radical produced from homolytic cleavage. So, we have four types of free radical here. First, we have methyl, when carbon free radical bond with 3 hydrogen here. And then we have primary carbon radical here. When this carbon attached to another one carbon, so I know that you already learned the type of classification of carbon and hydrogen. Secondary free radical refer to the carbon here. This carbon radical bond to another 2 carbon, and the tertiary carbon radical when this radical attached to 3 carbon. So this is the difference between methyl, primary, secondary and tertiary. So here class, this is the example. If we look at this example, increasing alkyl substitution will increasing the radical stability. Why this happen? This is because radical carbon is electron deficient. They are stabilized by substituents such as alkyl group. For example, here we have CH3. This alkyl group is electron donating group. So, if the number of alkyl group increase, the stability of radical will increase. Next, we look at carbocation. Carbocation form when heterolytic cleavage occur. How? Carbocation means that carbon that has positive charge. So, this is the example here. So, if we look here, we have 4 types of carbocation here. We have methyl, which is the positive carbon bond with 3 hydrogen. And we have primary carbocation, the positive carbon bond with 1 carbon. And secondary, if this positive carbon bond to the other 2 carbon, and tertiary bond to the other 3 carbon or alkyl group. So if we look at this example, increasing alkyl substitution will increase the carbocation stability. Why this happen? Actually, carbocation same like free radical just now, because carbocation is electron deficient. They are stabilized by substituents such as alkyl group, which is we know that CH3. And just now we know that alkyl group is electron donating group. That's why if the number of alkyl group increase, the stability of carbocation also increase. Next, the last one, we have carbanion. If carbocation is carbon that have positive charge, while carbanion, carbon that has negative charge. So look, here we have 4 types of carbanion also. We have methyl, primary, secondary and tertiary. So I repeat here, carbanion is carbon that has negative charge. So carbanion is vice versa from carbocation and free radical. Why? Increasing the alkyl substitution will decrease the carbanion stability. Why this happen, class? Carbanion is electron rich. So it has high electron density on that carbon atom. They are destabilized by substituents such as alkyl group. Why, class? We know that alkyl group just now is electron donating group. That's why if number of alkyl group increase, it will decrease the stability of carbanion. neon. Next, we look at reagent and site of organic reaction. The first one, we have electrophile. So, what is electrophile, guys? Electrophile is electron deficient species which accept an electron pair from a nucleophile. So, literally, electrophile means electron loving. Electrophile can be either neutral or positively charged. So, this is the example of electrophile species. We have the first one, Lewis acid, for example, aluminium chloride, iron trichloride, boron trifluoride. So if you still remember, boron and aluminium are incomplete octet. So that's why these species are electron deficient species. Another one, we have cation, positive charge, and carbocation, which is the carbon that has positive charge. Next, we have oxidizing agents such as chlorine molecule, bromine molecule or bromine gas. And then the last one, we have polar molecules such as HCl, HBr. Sometimes class, functional group also create reactive site. Electron-rich site react with electron-poor site. So, that's why class, we must first locate the functional group and the resulting electron-poor site and electron-rich site. For example, like this. So, this is electrophilic site, a molecule with low electron density around a polar bond. Means we need to know that this is a hot spot for electron to attack. So this will occur in a organic reaction later. So for example, we have carbonyl group here, haloalkanes, hydroxyl compound. If you look here, all the carbon atom here are electrophilic site. Next, we have nucleophile. So, nucleophile is electron-rich species that can donate a pair of electrons to form a bond. So, normally, nucleophile can be called as nucleus-loving. A nucleophile can be either neutral or negatively charged. So this is the example of nucleophile. If electrophile, we have Lewis acid. For nucleophile, we have Lewis base. Lewis base is electron donor such as anion. We know that anion is electron rich. Carbanion, species with a negative charge on carbon atom. Molecule with lone pair such as ammonia consists of lone pair on the central atom, and also H2O also consists of lone pair on the central atom. So all these species we classify as nucleophile. And then molecule that contain pi bond. For example, we have carbon-carbon double bond here, or carbon-carbon triple bond. So all these species are nucleophile. So for nucleophile site, we look at this example. So nucleophile site, a lone pair of heteroatom make it basic and nucleophilic. So normally nucleophilic site is molecule that consists of lone pair. So basic and nucleophilic site. So this is nucleophilic site. Alright. So normally the central atom contain lone pair or consists of double bond. Here is the general types of organic reaction. In organic reaction, we have four main types of reaction. The first one, we have substitution reaction. Next, addition reaction, elimination reaction, and the last one, we have rearrangement reaction. In substitution reaction, we can divide the organic reaction into three parts. First, we have nucleophilic substitution reaction. Next, electrophilic aromatic substitution reaction. And free radical substitution. For addition reaction, we can divide it into two parts. First, nucleophilic addition reaction. Next, electrophilic addition reaction. Later, I will discuss more about all these organic reactions. Okay guys, first we are going to look at addition reaction. So in addition reaction, all parts of adding reagent appear in the product. So two molecules will combine, become one product. Characteristic reaction of compounds with multiple bonds. So in addition reaction, normally will involve carbon-carbon double bond, carbon-carbon triple bond, and carbon double bond O. Two types of addition reaction. First, electrophilic addition. Second, nucleophilic addition. Electrophilic addition reaction will involve in carbon-carbon double bond or carbon-carbon triple bond. Sigma bond in carbon-carbon double bond and carbon-carbon triple bond are electron rich. So, this part is susceptible to attack by electrophile. So I will show you the example of the reaction. For example, we have ethene CH2 double bond CH2 react with HBr. So we are going to add HBr in the ethene molecule. What happened here? The double bond will break, form single bond. So I'll show you in expanded structure. So the original molecule consists of 4 hydrogen atoms like this. And now we break the double bond, become like this. So we are going to add HBr in this compound like this. So now we already added H and Br. So one compound combined with another one compound form one product. So this is addition reaction. Next, nucleophilic addition, mostly common reaction of aldehyde and ketone. We know that aldehyde and ketone consist of C double bond O. In C double bond O, nucleophile approach to the electrophilic carbon of carbonyl group. As we know that C double bond O in aldehyde and ketone is electrophilic site. So now I'll show you the example of reaction. For example, here we have ketone CH3 C double bond O CH3 react with HCN. So we know that carbon is electrophilic site. So what happened here? HCN will break here. So we know that H plus Cn minus. So Cn minus will attach to the electrophilic site because Cn minus is nucleophile. So the product will become like this: CH3, CH3, CO. No more double bond here. So one bond we put at the below. So we are going to add HCN. So H will attach to the oxygen because oxygen is electrophilic nucleophilic site. I'm sorry. So we put hydrogen here and Cn minus we bond with carbon at electrophilic site Cn. So this is the product. So two molecules combined become one product. Next, substitution reaction. In substitution reaction, two reactants exchange part to give new product. Characteristic reaction of saturated and aromatic compound. Normally guys, this reaction will occur in alkane, haloalkane and aromatic compound that consists of benzene ring. We have three types of substitution reaction. The first one, free radical substitution. Most common reaction of alkane. So remember guys, free radical substitution normally occur in alkane. But we have condition here, it must in the presence of sunlight, UV. So we know that the function of sunlight here to provide energy of homolytic cleavage. So I'll show you the equation example. So here we have methane. So react with chlorine gas. So if this reaction occur, it must in the presence of UV. So what happened here guys? So we are going to substitute or exchange the part in the reactant here. For example, we are going to remove one hydrogen here and replace with chlorine atom. So what happened here, you will get CH3 and one of the hydrogen already removed here and replaced with chlorine plus. So that hydrogen will combine with another chlorine atom form HCl. So this is free radical substitution. Next, we are going to look at second part of type of substitution reaction, which is nucleophilic substitution reaction. So this reaction most common of alkyl halide or haloalkane. Haloalkane must consist of halogen group. So I'll show you the example. For example, we have here CH3Br react with OH minus. So what happened here, the halogen group here will remove and replace with OH minus. So two reactant will exchange part here. So CH3 and then we substitute with OH plus Br minus. So this is the example of nucleophilic substitution. Next, we have electrophilic aromatic substitution. So from this name, we already know that this reaction only occur in aromatic compound, which is benzene ring. Why? Because benzene ring is electron rich. So benzene is susceptible to attack by electrophile. For example, this is benzene ring react with Br molecule or bromine gas in the presence of catalyst. What is the function of catalyst? Later you will learn about it in the aromatic compound chapter FeBr3. So what happened here guys? So in benzene we know that contain 6 carbon and 6 hydrogen. Here 1, 2, 3, 4, 5, 6. So each carbon bond to one hydrogen atom. So how to react with bromine gas? So that's why substitution reaction must occur here. So one of the hydrogen here remove and one of the bromine substitute into the benzene ring. So we are going to remove this hydrogen. You can choose any hydrogen and one of the bromine will replace the hydrogen. So the answer, the product that you will get here is like this. So hydrogen remove and we substitute with benzene. Not benzene, I'm sorry. We substitute with bromine. So the hydrogen remove will combine with another bromine atom form HBr. So this is the product form and this is the substitution reaction. Next, elimination reaction. Actually guys, elimination reaction is opposite of addition reaction. How? A single reactant split into two products. Just now, addition reaction, two molecules combine form one product, right? So actually elimination reaction is method for preparing compounds with double and triple bonds. So I will show you the example here. I choose the same product that we use in addition reaction. So for example, this product that I take it from addition reaction just now. Okay, so what happened here guys? HBr will remove from this compound. So one hydrogen and one Br here. Just now in addition reaction we add HBr in double bond, right? But now we are going to remove this hydrogen and bromine. So it will form like this. So actually for this reaction we need base. What base? So you will learn it in chapter 5. Okay, so the product that form here is CH2. I write it in condensed structure, CH2. So no more HBr here and double bond will form plus HBr as the side product. So from one reactant form two products. So this is elimination reaction. Okay guys, so this is the last part of reaction, which is rearrangement reaction. So for rearrangement reaction, a single reactant undergoes a reorganization of bond and atom. It means that we are going to rearrange from one compound become another new compound. How? Okay, I'll show you the example. For example, I take it, the class of compound is alkene. So here I have butene, CH3, CH2, CH, double bond, CH2. And then I will rearrange this compound or this molecule become the new molecule. How? So actually in this reaction we need catalyst. What type of catalyst? Later you will learn about it. Okay? So the product that I'll change it is like this. I will move the position of double bond, become CH3, CH, double bond. See? Double bond at position number 2. Just now, double bond at position number 1 and this. So look, I will change the position of atom, which is the hydrogen atom, and the position of double bond. So this is rearrangement reaction. So if you look at the formula is still same, C4H8. What I did here is I just rearrange all the atom here and the position of double bond. Actually, I just rearrange the position double bond and the hydrogen atom, because we know that class carbon must consist of 4 bond. That's all. Okay guys? Thank you guys. That's all for chapter 4.4. Finish about chapter 4, Introduction to Organic Chemistry. Later, you will proceed with chapter 5. Don't forget to answer the formative assessment about chapter 4.4 to ensure your attendance for lecture. Bye guys!